Well, looky. Today there was an article in physics.org. A newly discovered super Earth offers prime target in search for alien life. The discovery of a possible super Earth less than 20 light years from our own planet is offering scientists new hope in the hunt for other worlds that could harbor life, according to an international team including researchers from Penn State. They dubbed the planet named GJ251c a super Earth, as data says it is almost 4 times as massive as Earth and likely to be rocky. We look for these types of planets because they are our best chance at finding life elsewhere, said Severn Verheven, the Vernon B. Vernon Professor of Astronomy at Penn State and co-author of a paper about the discovery published in the Astronomical Journal. The exoplanet is in the habitable zone of the Goldilocks zone, the light distance from its star that liquid water could exist on its surface if it has the right atmosphere. For decades, the search for planets that well, might host liquid water and perhaps life has driven astronomers to design and construct advanced telescopes and computational models capable of detecting even the faintest signals from starlight. This latest discovery was the result of 2 decades of observational data and offers one of the most promising aspects yet for searching for signs of life on other planets, Irvin said. The exoplanet was found using data from the Habitable Zone Planet Finder, a high precision near infrared spectrograph, a complex prism that breaks apart signals from starlight fixed to the Hobby Adderley telescope at McDonald Observatory in Texas. Penn State researchers led the design and construction of the HPEF, built to detect Earth-like planets in the habitable zone of nearby stars. We call it the habitable zone planet finder because we are looking for worlds that are at the right distance from their star that liquid water could exist on their surface. This has been the central goal of the survey. This discovery represents one of the best candidates in the search for atmospheric signatures of life elsewhere in the next 5 to 10 years. Mervan and his colleagues made the discovery by analyzing a vast collection of data spanning over 20 years and collected by telescopes around the world, focusing on the slight movement or wobble of the planet's host star, GJ251. This wobble comprises tiny Doppler shifts in the star's light caused by an orbiting planet's gravity. They used the baseline observations to first improve the wobble measurements of a previously known inner planet GJ251b, which circles the star every 14 days. They then combined the baseline data with the high precision data from the HPF to view a second stronger single at 54 days, indicating there was another far more massive planet in the system. The team further confirmed the planet's single using the Yid Survivor built by Penn State researchers, which is attached to a telescope at the Cat Peak National Observatory in Arizona. We're at the cutting edge of technology and analysis possibilities with this system, said Corey Bird, qualified author on the paper who conducted the research while earning a doctorate in physics at the University of California, Irvine. We need the next generation telescopes to directly image this trend, but what we also need is community investment. Yep, here it is. The two planets. One of the biggest challenges in flying distance world is distributing the planetary signal from its star's own activity, a kind of stellar weather. Stellar activity such as sunspots can mimic the periodic motion of a planet, giving the false impression of a planet where there is none. To distinguish a single phone noise, the researchers applied advanced computer modeling techniques to analyze how signals change across different wavelengths or colors of light. This is a hard game in terms of trying to beat down stellar activity as well as measuring its several singles, teasing out slight signals from what is essentially this flowing magnetic pattern of a star surface. He explained that discovering exoplanets like GJ251c requires advantage admits in complex data analysis. The work involves correlation across multiple institutions and expertise throughout the world, and most importantly, requires a stern commitment from the countries funding the research, which can often take decades to yield actionable results. This discovery is a great example of the power of multidisciplinary research at Penn State, said Eric Ford, distinguished professor of astronomy and astrophysics and director of research for Penn State Institute of Computer and Data Sciences. Mitigating style activity noise requires not just cutting edge instrumentation and telescope access, but also customizing the data science multitude for the specific needs of this star and combination of instruments, the combination of extra data and state of the art statistical also enables our interplanetary team to transfer the data into an exciting discovery that paves the way for future observatories research for evidence of life beyond our solar system. Well, the exoplanet that the team discovered is not possible to image with current instruments, but it said the next generation telescope would be able to analyze the planet's atmosphere, which could potentially reveal chemical signs of life. We are always focused on the future, he said, whether that's making sure the next generation of students can engage in cutting edge research or designing and building new technology to detect potentially habitable planets. The newly found exoplanet is perfectly positioned for direct observation by more advanced technology, and his students are already planning for when more powerful telescopes, the new generation of 30-meter class ground based telescopes come online. Equipped with advanced instruments, the new telescopes are expected to have the capability to image nearby rocky planets and habitable zones. While we can't yet confirm the presence of it as a for life on GJ 251C, the planet represents a promising target for future exploration. We made an exciting discovery, but there is still much more to learn about this planet. Um, it's 14 days to spin around that star. Um, yeah, I mean, it's probably tidally locked. One side is getting all the sun, the other side's dark, so life would probably be the temperature zone. Um, and there's also the problem of, like a 430 AB. I mean, was what's extremely helpful, but it turned out its star was really violent, and there's a lot to consider. Um, so it is interesting, but we'll have to see what the future holds.